So again, welcome to the training today. Our agenda for today, we're going to, of course, have some introductions. I'm going to introduce myself as well as a couple members of the organizing committee. We're going to have our hackathon objective, our deliverables and resources, some general information, and then the main thing that everyone has come for, our data to dashboard training, which I am so excited about. It's one of my coworkers that does some fantastic work at the Texas Advanced Computing Center, and I am really looking forward to her presentation here. John, if you wouldn't mind keeping an eye on the chat as well, because of course, as long as I am full screen, I can't see any of that, and let me know if there are any questions. By the way, let me just mention, I don't know if you know this, but we are 2 weeks away from our kickoff. We have one more training session after this one, and then we kick off on November 4th. So it's an exciting time in the world of HPC in the city. Our organizing committee here, we have Mr. Alex Nolt from the University of Tartu. He's actually over in the European Union right now, but that's where he lives. In Estonia, we have Miss Amy Cannon from Omnibon. We call her, she is the heart of our group. She's been with us from the beginning. Mr. Boyd Wilson, I believe he's actually here as well. He's a part of Omnibon. It's supporting us from the beginning. You all heard from him last week when he did an amazing presentation on Google Cloud Platform and Cloudy Cluster. Of course, you can check that on our hackhpc.org site if you want to go back and review that. Dr. Linda Hayden, which is my mentor for years and the one that had the vision to bring us together. And then I myself am Jimmy Powell. I am the one that inundates you with emails letting you know, hurry up and get to the training. So we're all here. And any of my organizing committee members, if you're here, would you mind saying hello? I think I saw Boyd out there.
Yeah. Hey, how's everyone doing?
There we go. Hey, Boyd. Are there any other organizing committee members out there? All right, just want to make sure. So the objective of the HPC in the City St. Louis hackathon is to harness the resources and skills that are found within the high performance computing HPC community, bring them together with students and members of academia, so professors, as well as members from the vendor community, put them in a room, virtual room in this case, to work on problems related directly to the participants. In this case, we're focusing on problems that affect the St. Louis area. They're going to develop knowledge about solutions to identify issues affecting St. Louis through the application of data analysis, presentation, or management. Some of the student outcomes, you're going to have an increased familiarity, of course, with science in the cloud and HPC technology. You're going to experience the joys of collaborative software engineering. If you've never done that, I promise you, it will be fun. And, hint, hint, wink, wink. We no, it's actually a very powerful tool. And of course, you're going to learn methods on how to do that. And then, of course, you're going to develop some professional communication skills as you present your various projects. Now, as far as the student deliverables and resources, the deliverables include a GitHub repository that your team will make. And in that GitHub repository, you're going to, of course, have a copy of your code, your source code, with comments, please. Put comments in your code. Be kind. Put comments in your code. You're going to have a PDF of the presentation you're going to deliver that includes pictures of your team members with their names. You're going to specifically say how you use HPC technology in the project. And you're going to also say how your project regionally affects or has regional implications towards your project. As well as hopefully give us a demo of what you come up with. The GitHub repository will also have a readme.md, so a readme.markdown file that gives information on what your project is about. All of these things are required prior to your presentation and as a part of the judging process. The resources that you'll have available to you include Google Cloud provided credits, By the way, just to throw out there, just as a reminder from Boyd's presentation, you can get credits now and even go through some training sessions if you'd like using Quick Labs. And those links are actually going to be on our site. Cloudy Cluster. Some of the most commonly used software packages or software languages include Python, which you're going to see a bit more today in Lissa's presentation. Jupyter Notebooks, Node.js, Ripplet for collaborative environment, and HTML. And of course, our main communication platform is Discord. If you're not a part of our Discord now, what are you doing? Please join the Discord, because that is going to be our main source of communication, both from we, the organizing committee, as well as your teams and your mentors. Join Discord. The 3 T's for everyone. Teams, there are going to be about 4 to 5 students per team with 1 mentor and 1 specialist or co-mentor. Those teams are going to be formed on kickoff night. Now, there are some students that I've talked before in the past and they've thought about working together and things, but in effect, the teams will be formed on the night of November 4th after seeing some of the mentor presentations. They're going to do 1 minute, 1 slide lightning talks to say, please help me with my project. And you choose them by joining their group. So it's going to be an interesting time. So it's going to take place November 4th through the 8th. On the 4th, we'll kick off at 6 p.m. Eastern. That's 5 o'clock Central and 3 o'clock Pacific, where we have, of course, team formation and the mentor pitches. Then the 11th, the 5th through the 8th, we will meet at 11 a.m. and 6 p.m. Of course, you can adjust for your time zone for our check-ins. And there'll be some interesting little events during the check-ins. I love giving prizes. Love giving prizes. Our sponsors have given us, have been so very generous to give us funds so that we can give prizes to you all. And then, of course, on the 8th at 6 p.m., you invite your family and friends and professors to come and see you actually present what your team has come up with. And we always look forward to that day. Some topic examples include data analysis in COVID-19, economic disparities, genomics, weather modeling, social justice, AI, public data, graduation rates, broadband access, and the list goes on and on and on, because even things, even though we're focusing on St. Louis, generally speaking, if it's something we're all dealing with, then it counts towards St. Louis. Having said that, I get to shut up, which I love doing. And I get to hand the floor over to Miss Melissa Pearson, Lissa at TAC. So Melissa, what I'm going to do is I'm going to go ahead and stop my share. And I am going to hand the floor over to you. So Ms. Pearson, you have our attention.
And now I just need to share my screen and present to you all. All right. Can y'all confirm you are seeing the presentation again?
Yes, ma'am. We are good to go.
All right, perfect. So today I want to talk to you all about the process for trying to create a database dashboard. And the inspiration for a lot of what I'm going to try and talk about here is sort of lessons learned from trying to work with people on this process. A friend of my ex-colleague came up with this BLUF term one time, and I learned that, and I thought that was fantastic, and that stands for bottom line up front. And so I was just trying to talk about my bottom line of this talk up at the beginning. You have a framework to put what you're going to learn into. My goal coming out of this talk is you all have a better sense at a high level overview for the process. And that will kind of touch on a lot of the technologies or specifics, but you're not going to learn how to do those in this talk. But that this talk and some of the resources here would be a touch point you could come back to and really dig into when you're trying to learn how to do those things, so that it is the talk is more like signposts and goals and giving you a map that you can then use to come in when you're trying to do this work. So with that said, the overall structure, I want to just go at a high level over the workflow that I generally see in these projects, kind of going from what people seem to think they are and then digging into the reality of how it actually goes. Trying to turn some of the unknown unknowns, at least into known unknowns for you all. The next section, I'm going to do a demonstration of applying this workflow process to a use case. This is one I just sort of came up with off the top of my head in order to have a demo project to show you all. Thinking about geospatial areas that are useful and how that links to data. And so it was like, oh, let's use Texas Congressional Districts as a base. When you see this application, there are links to it. It is very rough. This is still very early in this process. And that's both where it got to, but also intentional, because you all are going to be coming in at early steps and there's lots of groundwork and things are rough as you go along and it proceeds to get better over time. And then the last point I want to cover in this talk, if we have time, if we don't, this will be a section you can come back to or we'll get touched on some other talks, is some of the specifics of data cleaning and wrangling, tidy data, because as you will see, this is one of those unknowns that I want to turn into a known unknown for you, so you are aware of the work that needs to happen and what things expect. So with that said, the data to dashboards workflows. So a lot of times starting one of these projects, the workflow in people's heads looks like this. Hey, I've got some data. They turn to me, they're like, can you make us a dashboard? We'll just wire up some code, it'll be quick and easy. Data cleaning. Nobody thinks about data cleaning. Your data comes in the format you get it. Your dashboard needs it in a particular format, and you have to make those connect. Everyone's like, shouldn't be too hard, small amount of time when you point it out. You also have to visualize that cleaned up data. You get your messy data, you clean it up, and you have to decide how to present it in the dashboard such that the end user looking at your dashboard makes sense out of what you've given them. The goal here in a dashboard is to provide information to a user in a way that they can interpret and understand and use, not just have it look pretty, but be usable. And everyone underestimates the amount of time that those data cleaning, piping, and data visualization steps will take. In general, for a data dashboarding project, you should expect that the data cleaning, moving it around, reshaping it, figuring out how you want to display it, all of that part of the work, that will be 80% of your project. No one thinks about it, and yet it's the biggest part of what you're going to have to do. These projects are also, when done well, agile and iterative. If you're not familiar with agile versus waterfall or what that means, it's really the idea of you set your specifications, everything you're going to do at the very beginning, huge over scope of project, and then proceed like a waterfall step by step? Or is it a more agile, iterative communication feedback, getting back into the process and you're cycling? And these projects work best agilely, where you get through some steps and then you get user feedback coming back to feedback toward the beginning, and you go through the steps over and over again. So with that said, this is how I envision the development cycle for a dashboard project. You start with the dashboard design, what you're trying to do, move through collecting the data, you pipe the data and move it, you build some dashboards, you get user feedback, and feed that back into your dashboard design concept and modify what you're trying to do. And a lot of times, the iterative cycle, it's not shown in this, but it'll even short circuit, right? Because you're going through your dashboard design, you get to collecting your data, and you realize that data just doesn't exist. So you go back Or you get to data piping and realize there's an issue with where the data is being collected from, and so you have to get back. So you can imagine that there's these eddies in this flow all the time, but it's just this iterative cyclical process, the steps touching back to the parts you've done before. In a larger scale project, you'll go through a bunch of these cycles. For you all, it might only be 1 or 2 because it's a short, quick pack. That's sort of how these are done. But just kind of this idea of you're coming back to the beginning and touching base with the earlier steps, and that's to be expected. All right, so the steps, went over them. There's basic dashboard design. What am I trying to show to people? What's the goal of my website? What should it look like? What am I trying to accomplish? That goal should always be where you start of what you're trying to do. Once you know what you're trying to do, you can go out and try and collect the data to do that thing, to answer the question you're asking, to tell the story you came up with. Okay, then you need to move the data around, shape it into the form you need it in, create those visualizations from that data that you want to show to people. And normally that is a code development step, separate and upstream from the actual building of the dashboard. You do the work to figure out how to take your data and turn it into the story that you want it to have in somewhat of a static form. You know, like you're running a report, or you're doing, I'm running this right now, what does it look like? What dashboards give you is that interactivity element to allow a user to interact with your data, to change a piece and respond to it. But the code development and code work you will do to build a dashboard and make it interactive is really separate from how you wrangle the data in the first place. And if you keep those separate, as you do the work to develop these, it's helpful because when you get in the next cycle and you come back to a part, it makes it easier to find the piece you need to return to do the work on. And then user feedback. You want to present it to someone and get their feedback on how it should, what worked, what didn't, where they're confused. Depending on the stage of the cycle, this could be more or less informal. This can be as simple as you Slack somebody in your team and are like, hey, can you take a look at this? Does this make sense to you? Because when you build something, it is almost impossible to see the parts of it that are confusing to somebody else, because you know how it all works. There's a big pothole in your process and you just sidestep it every day without even seeing it. Someone walks in and they fall flat on their face. And I will take a point here that this is a new presentation for me, some new resources I've developed. I would very much welcome your feedback on things that made sense or didn't make sense. Because what I have here is a presentation, but also a GitHub repository and a website that are supporting the demo we're going to show. And I would like to make those more useful to people over time. So please, and if you send me feedback, I will incorporate that and I will update the code to reflect the next iteration. Okay. So I wanted to go a little more detailed into each of those steps. That was the quick overview. We may go through it somewhat quickly to make sure we focus on the demo, but I also wanted there to be the slides here. So if you're coming back, the things we're saying would be documented as notes for you all. All right, so the dashboard design. The dashboard you're building will frame the problem that you're talking about and tell the story that's in your data. It's a lot like the English project or history project you work on in school, and the 5 whys. You need to think about who your audience is, what information they should get from your dashboard. They come to your dashboard to answer a question. What will they take away from it? When there's temporal connections between the dash and your data, like is it live data that's changing? Are you taking a snapshot? Like sort of the questions about that fourth axis of time. People often forget about it, but it can come in and be important and sneak in. for this one, Congressional District, I have a map that I will show you in a little bit. It's of the 116th Congress. Those maps change. There's lots of discussions right now about what they're going to be. So you'll see that that was one of the parts of my data that I flagged was this is the 116th Congress. That may not stay the same, that may be different. Where people will access it, how they'll get the information. And of course the why, your overall goal, like why am I doing this? And when you get to the data visualization piece, because a lot of these are driven, it is the question of what chart, what image, what visualization best communicates the information to the user that I'm trying to show them. I'm trying to compare two things. I'm trying to show relationships. What chart should I use to show that? I took this slide out right here, but it's in the resources. There's a great almost, flow chart available to you to say, okay, what am I trying to do? And to get you to some of the choices you could make for which charts to use to answer that question. Okay, from this step, the output that comes out of this step for me is some kind of site mockup. The tools I use for that are things like whiteboard, pen, and paper. You will see this is often rough. It is just, mock up. Here is the screen. I'm coming to it. Here are the parts of the screen. What's there? Okay. The next step, data dashboard. You need to have some data. And then there are questions of what data do you have access to? What questions do you want to ask of the data? And then what questions can you answer from the data that you have? For most of these data dashboarding, since you are not in at the experimental design step, you aren't saying, here's the question I want to answer, and here's how I will design my data collection to make sure I can. You are working from pre-existing data sets, and they may not be perfect for the question you want to ask. So you need to sort of do the best you can, maybe tweak the question you're asking so it's very related to the question you really want to know and can still give insight into that, but properly framing it because the data you have available to you doesn't perfectly answer the question you want. For COVID, that would be one that comes up a lot. You'd really want to know at a very fine-grained level, say, where you're seeing cases. But there's HIPAA rules, and they only release that data down to a certain level. So you have to roll it up. What can you answer from that data? Or, ideally, you'd want to know where people live or work or what have you, but that's not what you have. The location of where a case was decided is somebody determined. I got a case, and we're going to assign that to a zip code based on where we tested, where they live, who knows. That's the data you have. That's what you have to work with. Can't always get what you want. So do what you can with what you've got. So output from this step, collecting the data, for me, this is a lot of documentation, can just be notes. In the repo that I give, you'll see in the README just saying where you got the data from, where the files came from, data dictionaries. For me, those are often either a document or a spreadsheet, something that explains, here's the data I've got, here are the variables, here's what they mean. This is very human level readable information to say, here's where things are, here's where you find them, here's where we got it from. For this, a lot of times you'll probably, unless you're just pulling data as URLs, if you're doing any transformations later, you might have a file directory where some place for you to store the data that you've collected. All right. And for me, the tools for this are often my local file directory, shared Google Drive with other people on the team, a GitHub repository, an actual place to put the things that I've decided, where is this going to go? All right, data piping. Data lives somewhere in some form. For your dashboard, you need it to be properly structured in a location where your application can access it. There's often a lot of steps in between that pipe those together. You think of it, it can be very similar to plumbing. there is water in a reservoir, and somehow that water gets turned to the clean drinking water out of my tap. And it gets moved between places. At the water treatment plant, it gets transformed because they take all of the things that will make me sick out of it or kill them. And then they pipe it to my house. Water piping, data piping, very similar. We're going to take the raw data in. You will either write scripts or use other people's if they're available to take the raw data and transform it into the shape and style of the data that you need. You will likely need to identify data storage locations. Sometimes it's okay to just constantly do those transformations on the fly, but sometimes you'll want to do the transformation on your data and then create a new data file that you store and keep coming back to. You'll have to handle moving the data between locations. You get it from somewhere, you need it to be somewhere else. As we said, somewhere your application will be able to access it. And again, just tapping in here on this point, data that changes over time. That not everyone, it is really easy to come and be dealing with data and we're dealing with it right now and not realize that data, that there's that temporal aspect. Things will change over time, which pieces will change over time, and just being prepared to handle that. Sometimes handling that can just be as simple as in your documentation saying, I downloaded the data on this date. So it is a snapshot of the data from, October 20th, 2021. And so then if someone runs it again 5 months later and something's different, they'll have the starting point to be like, okay, we ran the data. What changed in the data in those 5 months? Okay, so the output that I get out of this are any code that we've written to transform the data, any of those intermediate output files of data, and there aren't any of these in this project, but database connections. If some of these data transformations are happening at external databases, sometimes you'll need connection information to let your application hit that database and get data back out from them. Again, tools I'm often using for writing these, Jupyter Notebook, that's where I do the bulk of my data transformation writing because it's just easy and very iterative for yourself. You load it in, you see what you've got, you try something, figuring out, that's my almost, Jupyter Notebook for me is like a scratch pad as I'm working through the code to come up with something. There is a Jupyter Notebook in the demonstration repo that you all will have access to. I will point out that is a cleaned up and commented Jupyter Notebook. I tried to make it neat for you all. Probably not perfect, but I tried. The ones I'm often working with for real as I'm doing this are messy, and that's totally fine. You're coming back, you're just trying to store some of that pieces so you can work with the data and know what's going on. I say Conda, if you're writing code on your computer, you have something to manage the packages that you need from other people, the libraries of code other people have written. I use Conda, people use pip. Either are good, just a note there. And then GitHub for this one, a lot of the outputs from here do get stored in GitHub as a shared repository. Okay, so all of this has to happen before it makes any sense to try and even start building the dashboard, because it's all upstream work. Okay, now I'm ready to actually start building a dashboard. I build them mostly in Dash. Plotly Dash as the basis. There are other tools, but that's what I'll be talking about. So those upstream steps need to be in my Dash application, but most of the time that part of the work is super easy because it's really either just copy and paste. In the repo you have, I have copied and pasted the library imports and the data wrangling pieces directly into the app.py file that runs the application. In many projects, I will put that part of the code set into its own file, standalone file that I then pull into the Dash application to keep them separate. You then have to lay out the elements on the page. Here's where the things go. And then you need to wire up the interactivity you talked about. If you want someone to have a drop down to filter the data, well, you need to wire up the connection between that drop down and the other parts of the page. In general, those are referred to as callbacks. A user does something, that event triggers a callback to the page. It calls back to the code to say, hey, I need you to do something different, and creates a change in the website that a user is seeing. So the output from here for me is this directory of the code to build the application, the big part of which is this app.py file, that's the application. And then in development, deploy it either locally, which is as simple as running from the command line Python pointer to code, and then it launches it on my computer screen so I can see what it looks like, or then deploying it somewhere to the cloud so that I can demonstrate it to other people. Some projects will have somewhere internally to the cloud or to internal servers, you know. So for many projects, it's on a web server somewhere for the company where people have decided. For this project, and one you often will use, there is a platform called Heroku that you can have free websites, and so that you can just copy your code and launch it to Heroku. And for Dash apps, there's a very simple, if you have a GitHub repository, you can launch it to Heroku app very quickly and easily. I don't have screenshots of that process in here yet, but we'll add them so that I've taught someone to do it in probably 10 minutes, quick and easy. And so here, the tools I'm usually using are Plotly Dash. The IDE I personally use is Atom. There's lots of good options. And again, repository and GitHub. Big piece, form should follow function. Everyone wants to make their dashboards pretty. Everyone starts talking about pretty at the beginning. First impressions do matter. Pretty doesn't matter if it doesn't work. Your user, if they come to your dashboard and like, it's lovely, and they try and use it and can't do anything, they will leave frustrated. So form follows function. All right, and then the final step, user feedback, demonstrate the application to somebody. As we said, super simple, or it could be more formal. A useful thing, especially if it's not someone on your team, and especially if it's a non-tech user, is to find a way to actually watch them while they interact with your dashboard. So you can see what they're doing, and when they say they're having a problem with X, you actually understand what they mean, because there can be a lot of miscommunication because you don't understand the problem they're trying to convey to you. And if you watch them use it, that can often make things a lot clearer. So you get that feedback, and then the feedback goes back in and reinforms changes to your dashboard design and what you want to do next. And a key question to come out of this, touching back into that why question we talked about at the beginning. Did your dashboard successfully tell the story you were trying to tell, or aid a user in making the decision they came to make from it, right? Though it can be super pretty, it can be functional, people can have fun, but if they don't actually answer the question they came to ask, or that you were wanting to answer, then it's not actually successful. So the documents that output from this step for me is often some kind of way to document the feedback. People say things, write those down, keep them somewhere so you don't lose them. And the tools to do this ideally is a deployed website, something a user can actually use. But if you need to use PowerPoint or PDF, those are useful too. You just really want to get your work product in front of somebody else who can give you feedback on if it worked or didn't. All right, so let's look at an actual example. This is, as I said, quick Texas Congressional District one I threw together for this demonstration. The note here on the bottom, in case one of your groups works in Plotly Dash, I want to note that Dash just released version 2.0 recently. The Dash Bootstrap component library 1.0 is coming out as in pre-release. This application uses both of those. The differences between the 1.0 and 0.0 versions and the new one are pretty minor, just a little changes in how you import libraries or call them in your code. But if you mix them, it could cause something to break. So pointing that out in case this isn't 2.0, if you're using Dash, a lot of the examples, probably most that you'll currently find online, will still be in 1.0 versions. And so if you load them and mix and match and something breaks, go to the documentation for the, migrating from 1.0 to 2.0 to find them. All right. So the dashboard design step. What am I going to build? A dashboard to link Texas residents with information for their congressional district. And what did I want on the page? Selectable maps of congressional districts, a section with information related to the district, and then a table of clickable links to access information, files of information available for that district. I literally took, I cleaned it up, I redid it. So it would be cleaned up for this presentation. This is the cleaned up version. My hand sketch for myself, I don't think you all could have even interpreted what it was. But I literally sat with a piece of paper and a pen and just mocked up for myself. What should the page look like? So selectable map, table of districts linked with URLs, district specific information. Something I want to point out, these are the user actions. I put them on the page in a different color for myself. And I think of it a little bit in my head as the layout on the page, those blocks, those are the nouns. Those are the things that are there. The things a user does, those are verbs, those are actions you take. And so I'm trying to capture that for myself in one page to be like, here's what I have. Here are the things you can do to those pieces. All right, the next step, collecting the data. Needed to identify online data repositories. I need a map, so I know I need geospatial data. I need the geometries, the areas that define congressional districts. My next bullet, this is actually skipped ahead. I was like, I need some information about the districts to show something. Wound up being these PDF maps because that's what I found. This is actually has already had feedback in here because I was like, I need something. Let me go Google. And then the third one that I will show you how I would do it, because I didn't, was information on the individual members. That was actually my first thought on this project. I'll grab that. That became more data collection work than I had time to do for this. And so I've set it there as a to do for later. Okay. Collecting the data, geospatial data. Literally, Google this congressional district shapefile. Knew what I needed to find. Google is my friend. Right here, tiger line shapefiles. There's a repository. Go to the catalog, download the file. This is how I can find. For here, it's US Census data. Other things will be different, but there's a lot of going out and finding repositories of data elsewhere. For the district files, again, I just kind of Googled information on Texas congressional districts. There's a lot of, since this was on the fly, trying to figure out what is here to answer the questions. Found this site. There are downloadable maps from a dropdown that if you click on it, it takes you here and opens a detailed map of that congressional district. And then member information, which is as a to-do. This was an idea I had for this project, but it's sort of a set aside if it were to happen. There's a website with congressional information on the members. I'm showing this to you all because of something that you all could do for your projects. You open it up. I have it opened here with the developer tools. So I had filtered it, had a filter. I just wanted Texas. So the website available to me will filter all of those members to Texas. And then if you open the developer tools, I can see on the web page how the information for that individual Congress member is structured. And I could write a script to come in, scrape the website and grab that information and pull it in. And if I were doing it, I would pull it probably for me into a table with, they're in the strong bands. I don't know if you can see that. It has state and then Texas. And so state there would be my column header and then Texas would be the value for that. So I would come in here and scrape the website to pull the data, extract it into a table that I could use. But as I said, did not do that for this. We do. All right, so data piping. collected that data, but I need to transform it, move it, and shape it into what I need for my dashboard. So loaded the data into a local data directory and used a Jupyter notebook to do the data transformations, develop the data visualizations. So for geospatial, first thing I did, I took, I think GeoPandas actually can handle shapefiles, but at the time I was thinking, I don't want to deal with shapefiles. That's Esri's format for this data. I want it in a GeoJSON. There's a tool online called MapShaper. Took the shapefiles I got from the download, dropped them in here, and they spit out for me a GeoJSON of US Congressional Districts. And that output file is in the GitHub repo that I built for the project. And then in Jupyter Notebook, and this is what I'm talking about with the Jupyter Notebook code. And again, this notebook itself in the repository for this website is there just as an extra resource for you all. Loaded in that GeoJSON for the full US Congress, and then use a package called GeoPandas to take it. And I just want the Texas portion. So that is state with the ID number 48, pulled Texas out, and then I resaved for myself a new file called Texas Congress GeoJSON, very fancy name, that my application can use to just map Texas, because it will be faster for the application just mapping my one area. For the district map files, I load them in, but I'm also at this point using that to build my file of clickable links. So determined the pattern from the PDFs, like how that is built, where it's obviously this prefix, and it throws the district number in and then adds the suffix. Created a data frame for myself of that information to create a table, and then exported that sort of index table of pointers to those files into a new CSV that I can load into my application. All right, then I had my upstream stuff. I didn't show the part of building a map, probably add that, but that was also part of the data piping. Was I have a GeoJSON, how can I actually create the figure to make a map from it? And that, if you want to see the code, is in the Jupyter Notebook as so the application code. And so then I move into building the dashboard and build this app.py file. There are 5 parts. The beginning where I load libraries, the next step where it does the data loading and data visualization work, the actual part of the code that does the layout, the part where it does that wiring callbacks, and then the 5th little part that just runs the app. 1 and 2 we've already talked about, and I literally copy and paste out of my Jupyter Notebook into my Dash app file. That work's been done, it's there, now that's available to me, and then move into the layout and callback piece. If you wanted to use any of the resources here for you all to do this, just some steps for you that you can develop it locally. You can take the repository I built for this, clone it to your own computer, launch it, you work on it and modify it, and kind of take that as a starting piece to do some of this work for yourself, or just to dig in and see how things work. Okay. Looking specifically at the code out of the file you will find in there, there is an app.py file. The top, as I said, would look just like you strip it out of the Jupyter Notebook and throw it in. And I should note this is all written in Python. Plotly does have R and Julia support, but the bulk started in Python, and that's what I've done my work in. And you can see, for someone who knows some HTML, it's just laid out to put the pieces. Here in this app.layout, that's the part of the file that builds the actual layout, and then you have the component pieces. The way it's used, there's the HTML type pieces, divs, paragraphs, spans. This DBC stands for Dash Bootstrap Components, which just lets it use Bootstrap elements, rows, columns, buttons, anything that Bootstrap has available. And then the DCC components are, the Dash specific elements that build your charts and graphs and Dash specific pieces. And then you do the callback. For this one, you click on a map, click on the Congress, and that causes actions happen in the application. So the input is from that map, called labeled graph map. You click on it and you get information from the click. And then it uses the information it got from the click. Specifically, what I want is to say, hey, which congressional district did you click on? It extracts which congressional district was clicked on, and then it uses that to display to the user one of those maps that I showed you earlier for a district, and then a list of the files that are available that we have for that congressional district, which at this point is just the maps. And then user feedback. If I were doing this for you all, I would now demonstrate that app, collect some information, get some feedback, and decide what to do next. A big part of this, for as you do your projects, that I would suggest, feedback turns into issues that become tasks. Tasks need to be assigned to individual people and prioritized so people can know what they should work on next. Because you are a very loose group and it's a hack, that's probably pretty flat hierarchy, but I would encourage you to give one person the job of being point on that list and have input. And so you've decided what needs to happen next and who is doing those pieces. And so that there's one place when you are doing your own work and you're like, okay, I finished that. What should I go to next? You have a place to go and say, okay, the next task assigned to me with the highest priority is this. And you can pick it up and start working on it. Ideally, there'll be a place for problems that you run into. So you pick up a task, you're working on it, you run into a blocker you can't get through. You email someone or notify someone, make a note of that in the task management, whatever you're using, and then you can move to the next task on your list. So nobody gets blocked from forward progress because they don't know what's supposed to be happening or what's supposed to happen next. In here is the link for both the repository and application. Fantastic. While those are losing. So here is the repository. All of the code to build the application I've talked about is located here. It built up over time and pushed it to repository. This is the README file. The README file builds the front page of your repo. And so that comes here and you all could scroll through, see the discussion. I think Heroku is free and it spins up workers. So you can see it is still taking time. So we will let that load. And I'll come back to it. Oh, and so that's still loading. Popped up. Here we go. So this is what that code built. Map of congressional districts. You click on a congressional district, it pulls up the map for a particular congressional district. And then here you see it has filtered the list. You can click on one and it will open in a new place. Pretty simple and straightforward. It's not super complicated, but I hope that by picking this in for you all, it has a bunch of pieces that you could use. And if you were to dive into this code, you would have a map with shapes drawn on it, the ability to click to feed something else, a clickable table. Hopefully there'll be useful code for you in there that you all could use. Last quick 5 minutes, I just wanted to return to the data piping to turn to a key issue of data piping, which is the data comes in messy. You need to make it cleaned up and structured the way you want it. And this is one that hangs up a lot of people. So data cleaning and wrangling, super critical component. As I said, you don't always get what you want, can't always get what you need. Data comes in a lot of forms and it's usually messy. People do not normally provide nice, clean, structured data the way you want it. If you've learned how to code and you import a package, in either Python or R, and it comes with these data sets all nicely loaded for you. Somebody did a lot of upstream work to clean up that data set to give it to you like that. That won't happen in a lot of the projects you work on. The dashboards, the visualizations, require the data in very standardized formats. So you need to take what you get, clean and wrangle it into what you actually need. And so what you need quality control data. You need to make sure that the values are actually true and good. You need it where you can get to it, and you need it in the right structure. And as they always say, garbage in, garbage out. Give clean data in, and you get worthwhile stuff out. Garbage data in, garbage inferences out. Okay, so for quality controlling, if you're collecting your own data, you have the option to make sure it's good. Mostly you're not going to collect your own data. So for the pre-existing data, you need to review it for quality, assess where it came from, who the providers were. Do you trust that this is actually good quality data? And then you also need to handle missing values, because a lot of the downstream dashboarding expects there to be a value everywhere. How do you deal with missing data? And you might also want to do outlier cleanup. You know, if there's a point that seems way off, say it was sensor data, you want to look for ones where you're like, it was not 387 Fahrenheit anywhere on Earth in the month of March. That's a clear outlier, clean up the data from that. And then you want to keep track of where you got your data from and when you acquired it. You will often run into things that talk about this ETL that has some very specific meaning for certain processing, but in general, ETL stands for extract, transform, load. The general concept of those are very useful for you. You're going to extract your data from somewhere, from data sources. You need to transform it into the clean and shape you need, and then you need to load it into an intermediate place where you can use it for your dashboard. All right, last big point, and I've got 2 minutes, and we'll end on this. When you are shaping your data, you often need to make it tidy, and you will see that referred, tidy data. Lots of things assume you'll have a presentation, okay, and we start with this tidy Parquet file. People and dashboards expect tidy data. Okay, what does that mean? And I will just say here that the concepts for tidy data are language agnostic. I do it in Python. R is great for this with the tidyverse, but the ideas of what you're wanting to do with the data to make it tidy doesn't matter which tool you're using. Just use whatever you know best. And there's lots of in-depth for this on the resources. So final big point, tidy data, what is it? Each variable is a column. Each observation is a row. Each value is a cell. That is tidy data. You want your data in this format, and then it's tidy. To think of examples of where you often don't see this, the underlying data here, you can see, right? It says year. Year is a variable, and then each row says which year. Lots of data sets would come in with every year gets its own column, right? That's messy. So you just want to get your data cleaned up and structured as tidy data. Tools available to do that. And I think we are out of time. So I'll just point that here at the end of this slide, and I think Jamie can tell me how we can get this available to you. There's a list of resources for you to look into these tools. And the last one, this is the chart I was telling you about for selecting charts based on what you want to do. And so I'll leave that up as we end, and that's a good point to end.
All right. And if you wouldn't mind going one more slide for me there, Alyssa.
There you go.
Thank you so very much. And of course, I want to give you a hand. Thank you so much, Lessa, for that presentation. So the presentation that she just gave is a very common thing that the teams go through for the hackathon. And so being able to reference this as well as those resources that she provided will be beneficial to all of the teams. Those references and links are all included on the event site, which of course they're on the page, and the schedule will be added here soon. Just to add to that, We have one last pre-event training session that will be taking place on October the 28th, next Thursday, same bat time, same bat channel, where we'll have the beginning to end project example, which will be presented by our own Miss Jocelyn. And it's going to be an amazing presentation that we're looking forward to. Again, her contact information is there. Thank you so much, Lissa. You can actually stop the share and I will stop the recording as well. So thank you, everybody. And we'll see you next week for our last pre-event training session.
Thank you all. Have a good one.